Hello and welcome to another video. This time we're going to be looking at random numbers. As usual, the only tools you'll need are Nano and your assembler, Easy80ASM. What we're going to look at is two different methods of generating a random number. The first we'll look at using an internal timer within the Agon, and the second we'll use an already established Z8T standard method of generating a random number. So if we dive into our code, the first section is as usual. We're preparing everything for our program. And the data we're going to send here is simply going to put some information onto the screen. We're going to put up a title and some other bits of information. But the main section of the code is just here. We're going to keep in a continuous loop unless we press one of two buttons. We press the escape key and then we're going to exit. Or if we press the space key, we're going to go in and display some random numbers. So if we press the space key, we're going to a little loop here. And the first thing it does, it simply waits until we've released the key press. So we don't keep doing it again and again. And then it'll jump into these two routines, one to use the first method and the second to use the second method. So the first method, which is specific to the Agon, is that we're going to get a call to the system variables, and then we're going to take the first byte. Now what are we actually taking here? If we take a look at the Wiki page, you'll see that the system variables, the first item, is actually a clock timer. There are 4 bytes allocated to this, the first one of which is the one which we're running fastest. So the idea here is that if we grab that first byte, it will most likely be different to the last time we read it, and therefore give us a pretty random result. Once we've got that, we're going to print it to the screen with our usual print routine. The second method involves setting a seed at the beginning, doing various different mathematical calculations, and resetting the seed at the end and giving us an answer. So that next time it comes into the loop, that initial seed is a different number. The start of this looks a little bit odd, but what we're doing is we're representing LDA,0 in 2 bytes, and those are the 2 bytes which make up that instruction. And as it goes through the routine, it eventually changes the number represented as rand seed, which is seen up here, to be a different number. That is, so next time we run this loop, it has changed. This is sometimes referred to as self-modifying code, although in this case we're not changing the actual command, we're just changing the value the command is using. Again, we print that value out. So let's take a look how that looks on the Agon itself. If we assemble the program as usual, load it, and run, you'll see we've got the text on the screen, and it's asking us to press space for a new number or escape to exit. And every time I press space, it generates 2 random numbers, the first being based on the clock and the second based on the random seed. Each time I press, we get 2 different random numbers. You can try it for yourself and see if you think both of the numbers are pretty random.